Hello, listeners. I hope you are all fine. And today I will discuss about the basic principle and types of a very good analytical technique, which is called chromatography. And this topic is important with respect to various experimental work as well as in analytical chemistry or in other branches of science. First of all, we will discuss about introduction of chromatography. Chromatography is basically it's an important biophysical technique that is used for the separation, identification, and purification of the components of a mixture for qualitative and quantitative analysis. It means that chromatography is basically used to separate, identify, and purify the components of a mixture, and this technique is used both in qualitative as well as quantitative analysis. Basically, chromatography is the combination of two words, chrome and graphy. Chrome means color and graphy means to write. The Russian botanist Mikhail Svet was the person who first time used the term chromatography in 1906. In fact, he separated various pigments of plants like carotene, chlorophyll, and xanthophyll with the help of chromatography. And he first time used the term chromatography. He separated these components to column chromatography. After these chromatographic techniques get advancements, and in 1952 James and Martin they used gas chromatography for the analysis of fatty acid mixtures. Now there are various types of chromatographic procedures or techniques depending upon the nature of the substance to be separated, charge on the substances, size of the particles, and many other properties. In fact, chromatography is a very powerful separation tool or technique, and it is used in all branches of science. In fact, when we have to separate the components of a mixture, then the most preferable technique is chromatography for the separation of the components of mixture. Let's discuss the principle of chromatography. Basically, chromatography basically consisting of two phases. There are two phases in chromatography. First one is called mobile phase, and second one is called stationary phase. We must keep this thing in our mind that mobile phase can be a gas or a liquid, while stationary phase can be a solid or it can be a liquid supported on solid. Basically, the components of mixture, when passed through these two phases, mobile phase and stationary phase, they get distributed between these two phases. When the components have great affinity to the stationary phase, they remain or prefer to remain in stationary phase, and those components which have greater affinity for the mobile phase, they prefer to remain in the mobile phase. So in this interaction, the separation of the components takes place. So you can say that there must be a difference in affinity of the components with respect to mobile phase or stationary phase. In fact, the components interact with mobile phase and stationary phase that results in the separation of the mixture. Whose interaction is stronger in stationary phase, they remain behind, and whose interaction is stronger in mobile phase or affinity is stronger in mobile phase, that goes forward with the mobile phase. And that is basically the principle of separation of chromatographic techniques. Basically, if we talk about the basic principle, we can write this principle as in these words that variation the rate at which the different components migrate through a stationary phase under the influence of mobile phase. Definitely, when we pass mobile phase over stationary phase, the components of mixture distributes themselves between these two phases, and the separation depends upon the rate of migration. And definitely different components have different rates of migration, or they have different distribution ratios. Those who are more attracted towards stationary phase or more affinity for the stationary phase, their migration rate is low, and those components which have greater affinity for the mobile phase, their migration rate is greater as compared to the other components. So on this basis, they distribute themselves into various into two phases in various rates. so the separation takes place. Basically, the components migrate at different degree due to difference in solubility, adsorption, size, or charge. So there are different types of chromatography depending upon all these factors. We will discuss the types now. Chromatography can be classified on the basis of various factors. First of all, we talk about two types of chromatography: planar chromatography and column chromatography. This classification is based upon the method of separation. Either we are separating the mixture in column, or we are separating the mixture on a paper or TLC plates. So in planar chromatography, we use chromatographic paper, Wattman filter paper number one, or we use TLC plates. So planar chromatography, the examples of planar chromatography are paper chromatography and thin layer chromatography. While in column chromatography, we use column of various sizes, and all types of column chromatography, the chromatographies which take place in, or the separation takes place in column are fall in the category of column chromatography. For example, gas chromatography, high performance liquid chromatography, size exclusion chromatography, affinity chromatography, all are the types of column chromatography. So this classification based upon the separation is either taking place in column or on a paper or TLC plates. Then the second type of classification is based upon the mechanism through which the components of a mixture get distributed between two phases. Two phases means mobile phase and stationary phase. So there are three types of chromatography depending upon this criterion: adsorption chromatography, partition chromatography, and ion exchange chromatography. Basically, in adsorption chromatography, the components of a mixture get adsorbed on the surface of stationary phase. And in partition chromatography, basically the components of the mixture distribute themselves between two phases, stationary phase as well as mobile phase. And in partition chromatography, basically stationary phase is liquid, while in adsorption chromatography, stationary phase is always solid. What about ion exchange chromatography? Ion exchange chromatography, in which we can separate various ions and polar molecules. In fact, these molecules are get exchanged with the ions which are attached to the ion exchangers. Ion exchangers are basically the stationary phase used in ion exchange chromatography. When we pass the mixture of the components or the mixture of the ions or polar molecules, they get attached to these ion exchangers and they replace the ions which are present on ion exchanger. Therefore, as they are replacing the ions, this chromatography is called ion exchange chromatography. Those ions which are strongly attached to the ion exchange resins, basically they get eluted later on, and which are weakly attached to the ion exchange resins or replaced weakly are eluted earlier from the column. So basically, adsorption, partition, and ion exchange chromatography is a type of chromatography, or the classification is based upon the mechanism through which the components are being separated. Now, there is third type of chromatography, that is size exclusion chromatography. This chromatography is further divided into two types: gel filtration chromatography and gel permeation chromatography. Basically, here the separation takes place depending upon the size of the molecule, or you can say the geometry of the molecule. We will go in detail later on about all these techniques. Then there is fourth type of chromatography, and this classification is based upon the physical state of the two phases. For example, liquid-liquid chromatography. Liquid-liquid chromatography means that both the stationary and the mobile phase are in liquid phase. For example, paper chromatography. Then the second type is liquid solid chromatography. Liquid solid chromatography means that the mobile phase is liquid while stationary phase is solid. For example, TLC, thin layer chromatography. Then gas liquid chromatography. Here, gas is a mobile phase and liquid is a stationary phase. And the example is GLC. And gas solid chromatography. Here, the mobile phase is gas and stationary phase is solid. This is called GSC. In GSC, adsorption takes place, and in GLC, partition basically takes place. So this is all about the types and basic principle of the chromatography. I hope you get the idea. And inshallah, in next lectures, we will discuss paper chromatography, TLC, and any other types of chromatography techniques in detail. Thank you so much. God bless.